Hello, we are from kelibies and we are doing a study on bacteria population growths. My name is Nur Ufia Wafa binti Zulhai and here is our group member Firuz Aliyah and Aini Masita. Okay, firstly, I will discuss about the background of the study. So, bacteria are one of the living things that can grow and expand their population. So, basically, this study is about to find the bacteria population growth by using a mathematical calculation related to the first order ODE that we have learned in class. Okay, firstly, we need to find the general formula for the population of the bacteria growth manually with the first order ODE and the initial value that we have chosen. After performing the manual calculation, we will also calculate by using potential method to ensure our result. When we get the product, we will further discuss the development regarding the result and the calculation that we have made.
Produce model. We're going to talk about specific type of model, which is multi-gene model. Multi-gene growth model is frequently known as an exponential growth model. It is basically on the idea that we would expect population kind to follow some kind of exponential patterns. Ordinary differential equation describes the so-called multi-gene growth model. dn over dt is equal to mu n. Further stress, this equation describes the dynamics of an increasing population only when growth is unchecked. Growth rate is a production of the bacteria minus with that of bacteria, which is actually equal to mu. Furthermore, we are considering a closed system. We close off the borders so that there is no bacteria that is allowed to in or out. We're just basically considering the bacteria that we have got into the system only. What is the relationship between population and growth rate? If the population size increase, then that means the more bacteria are produced than die. That also means our growth rate is positive. If the population decreases, the more bacteria are die than produced, and it also defines the value of growth rate, which is negative. To get the general solution, we need to use the method for the separable equation. We need to separate, which means we will bring the dt to the right side and n to the left side. And we will get 1 over n dn is equal to mu dt. After that, we need to integrate both sides with respect to the t. Therefore, our general solution is equal to nt is equal to c e power of mu t. To get the constant value, we can substitute the initial value to the general solution. That we get nt is equal to e power of mu t. And not only we can use manual calculating to get the general solution, we can get the general solution by computing it into the Python software. As a result, we get exponential graph. Therefore, bacteria population growth can be modeled by using Malthus method.
Next, based on the result achieved, we can conclude that Thomas Robert had proposed a model for this bacteria growth population. He suggested to form a general solution where n is referred to total population growth after time, t is referred to time, and naught is referred to initial population growth, mu is the rate of growth, which is a constant. By separating the variables and integrating the two sides of the equation, we can easily get the general solution. And also, having an initial value to determine the constant values will lead us to the general solution of the problem. Lastly, the graph shows that the population has increased over time. We move to the conclusion. Basically, it is a study about bacteria growth population. We are using the concept of first order ordinary differential equation, which is one of the topics we study in the math method class. So generally, in our project, we apply the Malthusian growth model. Next, recommendations. This model of bacterial population growth was proposed by a human. Therefore, it must have shortcomings and the applicability of the theory will change over time. So, in order to overcome these problems, we provide some recommendations to maintain the applicability of this model. First one is by having more experiments time to time to always ensure the relevancy is appropriate. And lastly, we want to suggest to apply technologies in order to get the most accurate data. That's all from us. Thank you and Assalamualaikum.